Hello and welcome to my channel. Today we have Nissan Note 2015 with the 1.5 CDI engine. I think this is the Renault engine which is used on this vehicle, and the vehicle has come to our garage with the engine management lights illuminating on the dashboard. As you can see, I have just started up the engine and the engine management light is still illuminating. There was a red engine management light sign here, but I cleared once the fault while I was investigating, and this fault code or this the amber engine management light sign came on immediately after restarting the engine. So I'm going to investigate the vehicle and check for the fault code. What fault code we have. Let me connect the scanner to the vehicle. I'm going to connect this to the vehicle and see. Okay, and this vehicle has come to the garage on very low fuel, so I feel that the fuel level is too low that not to completely run out of fuel. So let me scan the vehicle and see what is there. So history of the vehicle. Okay, this is the fault code that we have. So one is for the preheating unit diagnose connection, one diesel exhaust fully with DEF, and this one is for the differential pressure sensor, this one, and this one is for heating system, the second one, which is P0380. So our focus is on P1453. We are going to investigate that. So keep this in mind that we have got P1453. Now we are going to go back. So let me go to the freeze frame data. So when the fault code was started, so that was, I think, from yesterday when I start the vehicle. So the water temperature was 39.3, as now it's I have just started the vehicle, and the temperature, let me check. As you can see, it's raining here outside. So this is the ambient temperature. It's approximately 5, 6, 7, 8. So that this fault code is from yesterday. Engine speed 2300 and 38, it means that the engine was running. So vehicle speed was 0, so vehicle was stationary. Soot and particulate filter 0, as you can see, 0. Exhaust system flow, blah blah. Let me go back. So I'm going to go directly to the live data stream. So I'm going to select the relevant topics or relevant items from the list. So I'm going to select relative item from the list and then show you. Okay, I have selected a relative item to the emission system, or related to this fault code, which we have P1453. So as you can see that now the engine is idling. So the engine is idling. As you can see, the rev counter is on approximately 950, something like that. And also, as you can see here, motor is running. Turbo regulation is inactive, so it's not active. So particulate filter, differential pressure correction, so both are, one is -1 and the other is positive, or just one. Atmosphere pressure sensor voltage is approximately 3910, so 3.9 volt. So turbo charging solenoid is at approximately 5% active. Boost pressure reference, this is very, very important. As you can see, the reference we should have had now, the boost pressure 1013 millibar, which is 1.013 bar. So particulate filter differential pressure, it reads 0 millibar. Let me show you what's the particulate filter differential pressure. So this is that. And as you can see, soot in particulate filter 0. Boost pressure 973. So let me bring the engine speed. We haven't got the engine speed. Okay, so now I'm going to rev the engine. As you can see, turbo solenoid is active. Boost pressure, this is the reference, this is not the actual boost pressure, but I'm going to show you the actual boost pressure is 900. And as you can see, this is the reference is up and this is down. So this is one problem. And also as you can see, the diesel particulate different pressure sensor is not changing at all. This is another problem we have. So as you can see, I'm revving the engine, but the diesel particulate differential pressure sensor is not changing at all. You know, the value is not changing at all. So this is the problem. This is the so the engine is at 4000 RPM, and as you can see, the boost pressure is 884, and also as you can see, the diesel particulate filter pressure sensor value is not changing at all. As you can see, the turbo charging solenoid is active 57%, and boost pressure sensor is 1539 millibar, which is 1.5 bar, and as you can see, that's much different from the actual boost pressure. And also this too is these two are not changing at all. So what do you think? What could be the problem? Could be, I'm not sure whether that could be the diesel particulate filter. But and another thing I am going to mention, and it's very important, that this car has come from another garage, and the garage told us that in last year August, the diesel particulate filter was replaced with the aftermarket diesel particulate filter. So they say the diesel particulate filter was replaced, and since then the car was okay. And recently the car was taken to Nissan dealership for this problem, and the differential pressure sensor was changed by the Nissan dealer, and the car is back. As you can see now, when I rev the vehicle, and the red engine management light sign has come on as well, and as you can see, the engine is still running. So we don't know what could be the problem. The problem could be that the pipe diesel particulate filter or post diesel particulate filter, which are connected to the differential pressure sensor, could be blocked. What else could be the problem? And also, when I started the vehicle, and now I can smell fume, not fume, actually emission, exhaust smoke in the inside the passenger or the passenger compartment here. So could be the rubber hose which is connected to the differential pressure sensor burst out, or whatever could be the reason. But the other problem is, I don't like about this car is it's very restricted. So as you can see, it's very difficult to work on this vehicle, and the differential pressure sensor is very far at the back here. That cannot be seen, it can't be felt by hand. That's here. But actually, to get access to the differential pressure sensor, you need to remove all this part, and then also underneath I have checked, the access is very difficult too. So I will not be able to show you the whole process, but whatever I found important, and I'm going to share that with you. I'm going to check the blockage of the differential pressure sensor pipes, pre-diesel particulate filter pipe and post-diesel particulate filter pipe. I'm going to disconnect the sensor from it and then see if there is any emission or exhaust smoke coming out of the pipes. When the red engine management light sign comes on the dashboard, and we have received this fault code. That fault code is added to the list of fault codes, which you can see that says temperature before particulate filter 1, diesel particulate filter 1, fluid DEF fluid. That's, I'm not sure that which temperature they are talking about. Temperature before catalytic converter. Okay, that's true, because that's going to be the temperature sensor before the diesel particulate filter. So the computer uses this information of this sensor, then the computer commands the AdBlue system to inject AdBlue, or that's the reason they have mentioned the DEF sensor. That's the top one here. So we are going to invest. Let me go to the back to the live data. So I'm going to check live data of that sensor. So I'm going to hold, put you on hold, and I'm going to bring that sensor on the screen, and then I'm going to show you. Okay, these are the temperature. As you can see, I'm going to rev the engine up. So as you can see, one temperature is changing. I'm going to steady hold the engine rev on 300. How can I hold that? As you can see, so catalytic upstream exhaust gas temperature is changing, but temperature upstream of catalytic converter stays at 50, but I'm not sure which one is which. So one is not changing and the other is changing, responding to the engine RPM, or as the engine RPM goes up, the temperature figure or digits also go up, but the bottom one is not changing at all. So if I go back to the engine management, so these are the fault codes again. So looking at the scanner is not going to help me, so I'm going to check manually and see what can I find. Okay, I have disconnected the differential pressure sensor from here, as you can see, and I have connected hose to the differential pressure sensor pipes. So this one, as you can see, I'm not sure you can see my finger, this is the post diesel particulate filter pressure pipe, this one, and this is the free. This is, so I'm going to bring the vehicle down and I'm going to start the vehicle and observe if there is any exhaust smoke, exhaust pressure is coming out of the pipes, any of them. So I'm going to start the engine and check if there is any pressure existed in any of this hose. As you can see, the engine RPM is at 3000 RPM, and this hose is from pre-diesel particulate filter, and you can see very less pressure. So it means that we have not got problem in the exhaust flow. The exhaust flow is clear. Now I'm going to connect this one. Any prevention to the exhaust flow. So we have connected both hose which is connected before diesel particulate filter, and hose which is connected after the diesel particulate filter, and both are approximately reading 0 pressure. So there is no restriction of the diesel particulate filter. Now we are going to investigate the sensor. So the sensor might be connected so wrongly. So the hose, this sensor, this hose might be connected wrongly, or whatever the reason is. So we are going to test the value of the sensor, this one. We are going to check the value, take the value of the sensor and compare with the manufacturer specification. If we got manufacturer specification in the O2 data. And also I can feel that pressure is creating, I can feel the pressure on my finger, that so the hose is not blocked. So let me check the other one. Yeah, there is on this one, on pre-diesel particulate filter, there is also a pressure. I can feel, so it means that the hoses are not blocked. Let me show you. As you can see, this is the postcard, and let me show you. This is the pre-diesel particulate filter hose. the 3 diesel particulate filter hose. And the engine RPM is at 3200 RPM. Okay, Nissan Note 1.5 CDI. This is my second day I'm investigating this. So yesterday I have done some other work, so today I have come back to this vehicle and I'm going to investigate. As you know that yesterday we checked for any differential pressure sensor hoses blockage, of if there is any hose upstream pipe or hose and upstream diesel particulate filter hose and downstream diesel particulate filter hose or pipe or blockage, so they were not blocked. So today I'm going to test the sensor itself. So to test the sensor itself, I'm going to show you the wiring diagram of the sensor. So this is the wiring diagram of the sensor. Okay, as you can see, this is the wiring diagram of the sensor. This is the electronic control module where the sensor is connected. So this is the sensor itself, B235 for this vehicle. The sensor code is 235. So number one wire is connected to pin 15 at the ECU, and number two wire of the sensor is connected to pin 23 at the ECU, and number three wire of the sensor connected to pin 19 at the ECU. So number one wire 15 from the ECU and the number one at the sensor, that's the 5 volt reference voltage, so supplied by the ECU, and the 23 at the ECU and number 2 at the sensor. This is the ground wire or add connection for the sensor. Number 19 at the ECU and number 3 at the sensor. This is the signal wire from the sensor to the ECU. So this is the manufacturer specification. It says that if you checked or if you connect the scope or multimeter leads, so positive to number 1 and negative lead to number 2, and you should have reference voltage 5 volts with the ignition on. So checking for supply voltage. Then number 5 at the ECU and number 1 at the sensor, ignition on. If you connect the positive lead or red lead of the scope meter or multimeter to pin number 1 at the sensor or pin 15 at the ECU here. So if that's in either position, so pin 15 at the ECU, pin 1 at the ECU, and leave the negative lead of the multimeter or scope to pin number 2 at the sensor or pin 23. So you should have 5 volt reference. So it says ECU output the sensor to the sensor. So this is going to be 5 volt reference voltage output from the ECU to the sensor. Then if you turn the ignition on and you connect the red multimeter lead or scope lead to pin number 19 at the ECU, which is this one, pin number 19, and pin number 3 at the sensor. So either there is no problem, but only if we didn't have signal here, then we should have checked here at 19 because of the integrity of the circuit or for open circuit or short circuit in the wire. So I don't want to go much further away from the circuit. So positive lead of the multimeter or scope to pin 19 at the ECU or pin 3 at the sensor. Ignition on, engine is idling, we should have 0.5 volt sensor input to the ECU. Then we are going to increase the RPM while the scope leads or the multimeter leads are on the same wire or on the same pins. So as you can see, 1903 engine 2000 RPM, we should have 0.8 volt sensor input to the ECU. Then 23 ignition on, we should have 0 voltage. So then we are going to connect the positive lead of the multimeter or scope meter to pin number 3 and then connect the negative lead or black lead of the multimeter or scope to a good ground or battery negative post, and we should have 0 voltage. So we are going to put this specification in practice and be with us. So this is, if you remember, this is the sensor pin function, like pins function or pins layout. So number 1 is going to be 5 volt reference voltage, number 2 is going to be ground for the sensor to the ECU, and number 3 is going to be the signal wire or this signal voltage to the ECU. Okay, as you can see, I have already connected the scope lead. The yellow alligator pin is connected to pin 1 at the sensor. This alligator, this alligator, this one. And let's say in another word. So the green lead, which is the positive lead of the scope meter, is connected to pin 1 at the sensor. That's connected here. And the yellow lead, which is the black lead of the scope meter, is connected to pin 2 or ground of the sensor here. So as you can see right now, ignition is off and we have 0 voltage. Now I'm going to turn the ignition on, and you see we should have 5 volt if we have a good reference voltage supplied by the ECU. So I'm going to turn the ignition to on position as you watch. So let me check that here. As you can see, ignition is on and we have 5 volt, approximately 5 volt reference voltage. So now we have proved that the supply voltage or the reference voltage from the ECU is good. So now next, so I'm going to I'm going to skip the step 2 because as you can see 15 or 1. So we already proved that the number 15 is when the ignition is on, it has a 5 volt reference voltage. So I'm going to skip this step. So we are going now to number 1, 2, 3, to number 3 here. So now I'm going to connect the positive lead of the scope meter to pin number 3 here or 19 here. So in this case, the yellow the red lead is connected to pin number 3, as you can see. So I'm going to bring that to the positive lead of the scanner. I'm going to disconnect this. So I have disconnected this one. Now I'm going to connect. Okay, as you can see now, number 3 pen of the sensor is connected to the positive lead of the scope meter. So now ignition is on. We have 0.5 volt, which is matched to the manufacturer specification. So now I'm going to start the engine. As you can see here, it says that engine idling, we should have 0.5 volt sensor input to the ECU. So now I'm going to start the engine, and then we are going to observe whether we will still have 0.5 volt or we will not. So I'm going to start the engine. Okay, as you can see, I have started the engine, and as you can see, the engine rev counter is approximately between 800 and 950 or something like that. And as you can see, we have less than 0.5 volt, which here it says engine idling, we should have had 0.5 volt. So as you can see, we have less than 0.5 volt. Now I'm going to wait a little bit, because the engine is cold and I have just started the engine, and when the engine is warm up a little bit, I'm going to rev the engine RPM to 2000, and we are looking for 0.8 volt that we should have. If we didn't have, then it means that either sensor is faulty or there is a problem with the diesel particulate filter. Okay, as you can see, the engine is approximately at 2200 RPM, and the differential diesel particulate filter differential sensor output is 0.34, which is below the manufacturer specification. If you can see, manufacturer specification says at 2000 RPM the output of the sensor signal should be 0.8 volt. As you can see, it's 0.34, while the RPM is higher than 2000, so it's approximately 2500. So our sensor output did not meet the manufacturer specification. Now we are going to prove whether the sensor is faulty or the diesel particulate filter is faulty. That is going to be next stage. So as you can see, manufacturer specification 0.8 volt. So engine running 2000 RPM. Diesel particulate filter differential pressure sensor output should be 0.8 volt, while that's 0 while this is 0.34 volts, so it's below the manufacturer specification. So this next step is checking the sensor ground circuit. I'm going to demonstrate this one as well to see if we have the circuit okay. Okay, I have connected the positive lead of the scope meter to pin number 2 at the sensor, which is the ground wire of the sensor, and also the black lead of the scope meter to the battery negative. And we have 0.03 volt, which is all right because the engine is idling, and that is acceptable. So that was the ground wire test of the sensor. Okay, now I'm going to disconnect this hose. I'm going to disconnect this hose. This pipe is for the sensor connected before catalytic converter or particulate filter upstream pipe, or with the bigger diameter, this one. So I'm going to disconnect this hose, and because it's very, very difficult, I will not be able to show you the procedure, but when I connected another hose to it, and then I will apply some slight pressure and see if the pressure change on the scope, or in another word, if the sensor output signal changed or increased from 0.35 to 0.8 volt or something like that. That's going to prove us that the sensor is functioning, the diesel particulate filter is not okay. Okay, as you can see, I have connected hose to the upstream diesel particulate filter hose, this one. I have removed, where is that? I have removed this hose from this metal pipe, from this one. This is the upstream diesel particulate filter hose. This one was connected here, and now I have connected hose to that. As you can see, this is the hose, and so I'm going to apply some pressure to this hose and then watch the signal activity. If the signal increases. Okay, as you can see, so with the ignition on, let me zoom out this. So with the, so with the ignition on, we have got 0.49 pressure, and now I'm going to apply a little bit pressure. So I'm going to apply it slightly, but unfortunately when I increases the pressure, the voltage is decreasing. So I'm a little bit suspicious that the sensor hose might be connected wrong, or around, what does it called, might be connected, the hose the sensor hose, like the diesel particulate filter upstream hose may be connected to the downstream hose of the sensor. So I'm going to as you can see now, approximately 10 psi pressure is applied. No, 5. Let me now it's so pressure is 0 and the voltage is reading. Let me check that's pressure or vacuum. Yeah, this is pressure. So now the pressure is 0 and the sensor output signal is to the ECU 0.50. Now I'm going to apply some pressure. So I have applied 5 psi pressure, as you can see, but the sensor output is decreasing. So I'm going to check once again whether the hose is connected in the right way, where those should be connected. So I'm going to rest the vehicle and check that once again. Okay, I have swapped the hoses over, and as you can see, we have here 0 voltage. So now I'm going to turn the ignition on. So I'm going to turn the ignition on. So ignition is on now, as you can see. Let me zoom that out. So ignition is on right now, and we have 0.51 volt, which is good. Now I'm going to start the engine. So I'm going to start the engine. So I need to put the camera here because by one hand I need to press the clutch pedal while I'm pressing the start button on my other hand. So now the engine is idling, as you can see, and we have here 0.54 volt, which is acceptable. That's okay because with the engine idling, with the engine idling 0.5 volt, which is all right. We have got approximately 0.54, and also this data which I'm using, this manufacturer specification is the older version of this vehicle. So the newer version of this vehicle, which I think it's F12. This vehicle is F12, but in the O2 data in the United Kingdom, the manufacturer specification for engine management system is not available. So this is the old version. That might be a little bit different, but anyway, so we are going on the right direction. So the engine is idling, the voltage is all right, as previously when the hose was connected in a different direction. So we had different voltage reading, different value reading. So when I swap the hoses, when the engine is idling, the voltage has increased. So previously when the hose was connected so opposite around way, so the voltage was decreasing while the engine was idling. So now I'm going to increase the engine idle to 2000 RPM and see if the voltage has increased. Okay, as you can see now, the engine RPM is at 2000, approximately 2200, and the voltage has increased to 0.67. So while here the manufacturer specification, it says RPM 2000, and we should have 0.8 volts. So I think we are in the right direction. So this time I'm going to connect the hose as it is and secure it, and then clear the fault code and drive the vehicle and take the vehicle to a road test drive and see if the fault code is returned back. So it's 0.69 RPM 2400 approximately. So I'm going to clear the fault code and take the vehicle to a road test drive. Okay, when the car first came, so this green pipe hose was connected to this pipe, and this black rubber hose was connected to this. So when I tested, so as the engine RPM was going up, the signal voltage was reducing, so I suspected that so the pipe or the hose might be connected wrong. So I have swapped them. So I brought green from here to here and this black from here to here. So when I started the engine, so let me, okay, so I brought this green hose from this pipe from here to here, and this black hose from here to here. And when I started the engine, the signal was responding very well. So when the RPM was going up, the signal voltage was also increasing. So now I'm going to delete fault codes and take the vehicle to a road test drive and see if the fault has returned. So when the vehicle came to the garage, this green hose was connected to this pipe, and the black, this one, was connected to this. So that was the reason it was storing fault code. So I have put everything back together, installed everything, air filter housing, connected the mass airflow sensor, and also put this dock. Now I'm going to clear the fault code. So ignition is on. History. Right. Let's see now. What can we do? Yeah, now it's connected. Okay, engine. Trouble codes. Okay, these are the trouble codes. As you can see now, they have returned to the past. I think my repair is going to be successful. Preheat unit diagnosis, that's not. So I'm focused on this too. So I'm going to go back and go to erase option, ignition on, yes, okay, yeah, read fault code again. Okay, no fault code has been found. I'm going to take the vehicle to a road test drive. When I have come, I'm going to show you the live data again. So now I'm going to take the vehicle to a road test drive. As you can see, I'm driving the vehicle. I'm at 40 miles per hour and no engine code yet come on. So as you can see, still no engine management light is on. So I'm driving on dual carriageway. As you can see, I'm still driving 40 miles per hour. No engine management light has turned on. No engine management light. Okay, I have come from a road test drive trip and now I'm going to check the fault code. So I'm going to park it here. So the scanner is already connected. Come on, get started. Okay, I'm going to check fault code. Just this fault code is stored, which is said preheating unit diagnosis connection, diesel exhaust fully with heater. They say the car didn't come for this, so I'm not going to continue with this one. So apart from that, the vehicle was repaired. So according to the garage allegation, because the garage did tell me yesterday that the differential pressure sensor was changed by the dealer. If that is the case, then the dealer had put the hoses wrong, but I'm not sure. God knows. So anyway, I might not realize this one as well, because this is in a very restricted area behind, as you saw. But when I applied the hand operated pressure, have to say hand operated pressure. So anyway, when I applied the pressure to the sensor, the pressure was going, the voltage of the signal wire was going negative, so it was decreasing. So then I realized that the hose might be connected wrong. So I hope that will helps. Sorry, my speech is very bad. So I hope that will help someone if they are confronted in the same situation. If you apply pressure to the differential pressure sensor and the voltage decreases, that might be the case that the pipe is connected wrongly by someone. If you got the vehicle that already someone played with it, so it's going to be the case that they hose or connected wrongly to the sensor. So okay, now as you can see, the pressure is reading very well from second line from the bottom, as you can see, responding very well.